Join me as I dive into the world of neuro-symbolic AI and try to unravel how deep learning and logic work together. Imagine a world where machines don't just recognize patterns, but also understand the logic behind them. This is the promise of neuro-symbolic AI, a groundbreaking fusion of deep learning and logic that's advancing artificial intelligence in ways we never thought possible. By combining the strengths of both approaches, neuro-symbolic AI aims to create more intelligent, more reliable systems. But what exactly does this mean, and how did we get here? Deep learning has revolutionized the way machines learn from data, enabling them to recognize images, speech, and text with incredible accuracy. But despite its successes, deep learning has limitations. It can be opaque, brittle, and prone to errors. On the other hand, symbolic reasoning, which involves using logical rules and symbols to represent knowledge, has its own strengths and weaknesses. It's great at tasks that require abstract thinking and reasoning, but it can struggle with complexity and ambiguity. The history of deep learning and symbolic reasoning is long and winding, with both approaches evolving over the years. Deep learning emerged from the world of neural networks, while symbolic reasoning has its roots in artificial intelligence and computer science. As AI researchers, we've learned to appreciate the strengths of each approach, but we've also come to realize that they're not mutually exclusive. The intersection of deep learning and symbolic reasoning is where neuro-symbolic AI comes in. By combining the two, we can create systems that learn from data and also understand the underlying logic. This has the potential to transform industries like healthcare, finance, and education. The development of neuro-symbolic AI is a story of collaboration and innovation. Researchers from around the world are working together to advance this field, building on each other's ideas and discoveries. One of the key milestones in this journey was the creation of neural symbolic networks, which integrate deep learning with symbolic reasoning. Another important development was the introduction of cognitive architectures, which provide a framework for integrating multiple AI approaches. Notable researchers like Bengio, Jeffrey Hinton, and LeCun have made significant contributions to the field of neuro-symbolic AI. Their work on deep learning and neural networks has laid the foundation for the development of neuro-symbolic systems. Other researchers, like Douglas Hofstadter and Melanie Mitchell, have explored the intersection of AI and cognitive science, inspiring new approaches to neuro-symbolic AI. Innovative projects like the Neural Turing Machine and the Memory-Augmented Neural Network have also pushed the boundaries of what's possible with neuro-symbolic AI. These systems combine the strengths of deep learning and symbolic reasoning, enabling them to learn and reason in complex domains. The development of neuro-symbolic AI is an active area of research, with new breakthroughs and innovations emerging all the time. Researchers are exploring new architectures, new algorithms, and new applications for neuro-symbolic AI. Despite the progress that's been made, there are still significant challenges to overcome. One of the biggest hurdles is integrating deep learning with symbolic AI. It's not easy to combine two such different approaches. There are technical challenges, like dealing with different representations and reasoning mechanisms. And there are also debates within the AI community about the best way forward. Some researchers argue that deep learning should be used for perception and symbolic AI for reasoning. Others think that we should focus on developing more hybrid approaches that combine the strengths of both. Whatever the approach, it's clear that neuro-symbolic AI has the potential to transform the way we interact with machines. To overcome these challenges, researchers are exploring new solutions, like neuro-symbolic networks and cognitive architectures. These approaches aim to integrate deep learning with symbolic reasoning, enabling machines to learn and reason in a more human-like way. The potential implications of successful integration are enormous. Imagine machines that can understand and explain their decisions, machines that can learn and adapt in complex domains. Neuro-symbolic AI has the potential to create smarter, more reliable systems that transform industries and improve lives. The impact of neuro-symbolic AI on the future of technology will be significant. It has the potential to create more intelligent, more autonomous systems that can tackle complex challenges. From healthcare to finance, education to transportation, neuro-symbolic AI will play a key role in shaping the future. As we look to the future, it's clear that neuro-symbolic AI will have a profound impact on our world. It will enable us to create more intelligent, more reliable systems that can tackle complex challenges. If you're interested in learning more about neuro-symbolic AI, I encourage you to do some further research and share your thoughts in the comments. You might also want to check out some videos on deep learning and symbolic AI to get a deeper understanding of these topics.